Hello, assalamu alaikum everyone. We will be continuing our topic capital budgeting technique as we were discussing in the last class. Today we are going to discuss internal rate of return (IRR). Previously we have discussed net present value. We have discussed profitability index. These were related to the discounted capital budgeting techniques. We have also discussed payback period and discounted payback period. Uh, and we started with the accounting rate of return. So these are all the techniques which we have discussed in our previous classes. Today we are going to discuss uh, internal rate of return IRR. This is a very important capital budgeting technique. So let's go to that slide of IRR. Okay. What is IRR? IRR is the rate of return which equate the present value of inflow with the present value of outflow. This is the basic definition of internal rate of return. I repeat that internal rate of return is the rate or a discount rate at which the present value of inflows uh, will become equal to the present value of outflows. Usually, outflows are occurring at the time zero, so there is no need to convert those outflows in the into present value if the project or if the asset is of conventional nature, because initially we pay cost and we pay cost at the time zero, so it is already in present value. But the future cash flows which are occurring from the inflows, uh, those cash flows will be converted into present value. And uh, if we apply such a rate which makes all the present value, all the cash flows, or the present value of all the cash flows equals to the present value of the cash outflows, that rate is called internal rate of return. In other words, we can also say that internal rate of return is the rate at which the net present value of the project or net present value of the asset become zero. Now, what is the method of calculating IRR? So it is not very easy or straightforward way to calculate IRR. There is a shortcut method that usually we say that IRR is the two-third of accounting rate of return, but this is just an approximation. The proper method of calculating IRR is the trial and error method, that we apply different rate and we try to reach as close as possible to the to a rate which equates the present value of inflows with to the present value of outflows. Uh, when we are applying or when we are using trial and error method, we also use interpolation. Interpolation means that by using two rates and by using the relationship of uh, rate and the present value, we try to calculate uh, a specific rate which makes that present value equals to the present value of inflows equal to the present value of outflow, or in other words, which makes net present value equals to zero. Okay, so what is interpolation? Here on the slide you can see that the formula of the interpolation is a plus a upon a minus b into b minus a. Now basically in this formula there are two words with capital letters and two words with small letters. Capital A is denoting a discount rate at which the present value of the benefits is greater than the project cost. In other words, A is the discount rate at which you can get positive NPV. Okay, uh, small a is basically the difference between the present value of benefits and the project cost of a at a dis- a capital A is basically the discount rate at which you are getting positive NPV. A is basically the positive amount of positive NPV. Okay. On the other hand, capital B is the discount rate at which you get negative NPV. Okay, and small b is representing the amount of negative NPV. Okay, I think this method is not so easy unless and until we solve it through an example. Okay, so we are going to solve an example. I hope that example will be helpful to you to understand that how to calculate internal rate of return. Okay, so let's suppose there is a cash flow. Okay, here you can see I have written some figures in this Excel sheet. So here we are supposed to calculate internal rate of return first, IRR. Okay, so for IRR, first of all, we have to apply a sort of discount rate. Okay, we have to apply you can say a rate at which the present value becomes equal to or net present value becomes equal to zero. So in order to find out that rate, first of all we go for trial and error. Let's suppose we will be using a rate I as 10%, 0.1. Okay, so 10% rate, what would be the present value of these cash flows which are written over here? So in order to find out, or I think we should solve it for horizontally. So I'm writing here. So what would be the discount rate factor? Okay, present value factor at 10%. Okay. So the formula is that 1 divided by 1 plus I, and the power of 1 is 0. 1. We have to log this column 10%. Then okay. So we have calculated the present value factors at 10% rate, and now we are supposed to multiply it with cash flows. So we will get present value. Okay. So when we multiply it by 1, we will get the same amount. And I think so these are the values. If we sum up all the values, we will get NPV. So first of all, I think here I should write NPV. So we are in search of a rate at which NPV becomes zero. This is our task. Okay. Although by calculating 2 or 3 figures, it is not necessary that we will get that rate, but at least we will get the data for the process of interpolation. Okay. So we get the positive NPV of 61,000, okay, at the rate of 10%. Yeah, you may recall that I have told you that there is an inverse relationship between the discount rate and the present value. If we increase the discount rate, present value will reduce. Okay, there is inverse relationship. So let's suppose if discount rate, let's suppose if we increase the interest rate to the 12%, okay, what would be the present value factor? We have increased the rate. We have increased rate to 12%. Let's see what would be the impact of 12%. 1 divided by 1 plus, 1 plus I is 12%. Okay, we have to log this. We have to log this uh, cell of interest rate and power n. N is 0 in for the 0 year. Then it will keep on increasing. So okay, and when we multiply it by cash flow, we will get present value. Okay, just a minute. We will get present value, and I can highlight here this present value. Okay, again we will perform the summation in order to find out net present value. Again here we get a positive uh, cash flow. So we will keep on doing this process until and unless we get one negative value. Uh, so for the third time, as we are doing trial and error basis, and we also know there is inverse relationship between uh, interest rate and the net present value. So we will keep on increasing interest rate. This time I think we should increase to 15%. Okay, and at 15% we will get the factors what 1 divided by 1 plus I is now 15%. Okay, power n. Okay, enter, and we will get Again another present value. We get the third column of present value by multiplying the present value factor with the cash flows. Okay, and we will convert, and after calculating the present value of each individual cash flow, we will be adding all the values. Now this time we get a negative value. So this negative value, this positive value is small a. Okay, so this is our small a. This is small a, and this negative value is small b. Okay, and at the rate at which we were getting positive, and mind you that we will take those rates which are closer to each other. Why? Because there is non-linear relationship, is a curvilinear relationship. If we take two rates which are far away from each other, in that case there are chances for the error. So in order to avoid that chance or that error, we will try to find out two rates which are very close to each other. So we are getting two rates. One is 12%, and we are ignoring the 10% right now. So at the 12%, we have uh, uh, we have the value of 33,000. We have the value of net present value of 33,000, which is positive. So this 12% is basically capital A. Is capital A. Okay, this 12% is capital A. Okay, and the rate at which we have negative present value, that is capital B. Okay, so we get all the four values as per formula. What is capital A, what is capital B, what is small a, what is small b. And this was our formula, that IRR will be equal to capital A plus bracket open small a divided by small a minus b, bracket close, b capital B minus capital A. This is the formula. Okay, so we are going to apply this formula over here. So IRR will be equal to IRR will be equal to sorry A A plus A upon A minus B multiply by capital B minus A. This is the formula. Okay, and we will be putting the values in this formula. What was capital A? Capital A was 12%. So 12% plus bracket. I think bracket a, small a was 33. Okay, divided by, in Excel we have to use multiple parentheses for accurate calculation. This would be A minus B. Okay? Minus minus will cancel out each other and will be added. And this, then again we will open the bracket and we will minus B, capital B minus capital A. Okay. So this is the formula. I'm pressing the enter. What 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 is that? Okay. There is there correction is needed, and that correction is, okay, I think there is a multiplication sign needed. Okay. So this is our answer. 14.5% or 14.55% is our IRR, and IRR means internal rate of return, and internal rate of return means that this is the rate at which you will get zero NPV from a project or from an investment. Okay. This is the rate which equates the present value of future cash flows, cash inflows, uh, and the present value of cash outflows. So, if we apply this rate on the cash flows, you can counter check that our answer, our present value would be zero. Okay, let's verify this claim by applying present value factor at the rate of 14.55. Okay, so 1 divided by 1 plus IRR. IRR is 14.55 power 0. Okay, and let's log the IRR cell. We have logged that cell. Enter. 3 decimal places तक हम इसे रखते हैं value, and we will drag down the formula. Okay, we will drag down the formula. Okay, and present value would be, when we multiply this figure with cash flows, and our cash flows are, and we drag down the same formula, we will get the present value of each cash flow. By adding up all the present values of the cash flows, we will get the NPV. And since we are applying internal rate of return, it means that the present value should be equal to 0. There is a very minor, you can say, figure 296, which is because of rounding off. ये राउंडिंग ऑफ की वजह से जो है हमारा जवाब में जरा सा दो, देयर आर टू रीजंस बेसिकली. एक तो ये कि जो 12% और 15% के दरमियान गैप था ना, इसकी वजह से आ रहा है. ठीक है। अगर इस गैप को हम और कम कर देंगे तो ये और बेहतर जवाब आएगा, ठीक है। और दूसरा जाहिर बात है कि ये थोड़ा सा राउंड ऑफ हुआ है वैल्यू, तो इस वजह से भी as I have said earlier, that the relationship between the interest rate and the present value is curvilinear. It's not a linear relationship. So उससे होता क्या है, मैं आपको इस बात को समझा सकता हूँ, कोशिश करता हूँ कि पेंट ब्रश पर उस रिलेशनशिप को बताने की कोशिश करूँ। लेट्स सपोज ये आपका जिसे कहना चाहिए ग्राफ है। यहाँ पर हम ले लेते हैं रेट यानी कि इंटरेस्ट रेट। इस पे लिखना बड़ा मुश्किल काम है, इंटरेस्ट रेट, सॉरी। और यहाँ पे होते हैं प्रेजेंट वैल्यू, ठीक है। So there is a inverse relationship. When we are saying inverse relationship, it means that we will get a downward sloping curve. But that inverse relationship is not linear it is non-linear. It means that we will not be getting the straight line, rather we will be getting a curve, a curve like this, okay। तो इस बार पहले वाले को मिटा देता हूँ मैं, ठीक है। A curve like this, okay। तो अब उसमें होगा ये कि when we choose the two rates which are far away with each other, let's suppose there are two rates which are far away from each other, so this curvy nature will disturb our answer, this curvy nature. So what we can do, we try to find out two rates which are very close to each other like this. So in that case here, this uh, line here, over here, this line, this one, this become almost straight line. So the chances of error will be reduced. I hope that you will get some idea about that. In very simple words, that since the relationship between the interest rate and the present value is non-linear, so our task is to find out two rates which are very close to each other for the interpolation purpose, so that the error of the curvilinear can be reduced. Uh, we can reduce that error. Okay, so this is basically the reason we try to find out rates which are very close to each other. Let's suppose if we have applied uh, instead of 12%, if we have used 14%, okay, in that case here you can see that the answer is reduced tremendously to 62, which is near to the zero, okay, comparing the values which are in hundred thousands, okay। So uh, if as we go closer with respect to the two values of capital A and capital B, our answer will reach to the zero, okay। uh, Otherwise we will get certain a very small amount because of the curvilinear relationship, okay। I hope, and here you can see that here we can see that the difference is of only 0.02%, which is very small. Let's suppose if we, instead of 14, we took 14.25, we get 14.25, we get only 33, okay। Let's suppose instead of 15 we get 14.75. Now we will get a very accurate answer here. Only 15%, only 15 rupees difference is here. As we are reaching, as we are closing the gap between the capital A and the capital B, we are moving towards the accuracy, we are moving towards the zero. So we are actually asymptotically we are reaching towards zero. So uh, although the relationship remains curvilinear, but by reducing the gap, we are basically trying to make that curvilinear relationship almost or approximately equal to the linear. So this is the way uh, we calculate IRR. I will repeat a whole process for the students in a just summing up all the process. That what, first of all, we should be very clear what is IRR. IRR is the rate at which you will get uh, uh, zero net present value from a project. You will get zero present net present value from an investment. Okay, this is the definition of IR. Now the second step is that how we are supposed to calculate IRR. In order to calculate IRR, the best way is to apply trial and error method. In trial and error method, what we do, we apply different interest rates to reach zero NPV, zero net present value. In doing so, if we get one positive NPV and one negative NPV, we will use interpolation method. Interpolation method can approximately calculate or near to the accurate, almost accurate IRR. In interpolation, the formula is that the interest rate which is getting us positive NPV will be considered as capital A, and the positive NPV will be considered as small a, and the negative NPV, at the rate at which we are getting negative NPV will be considered as capital B, and the amount of negative NPV will be considered as small b. Here you can see that our A is जो पुरानी values थी, I think we should keep ये 12% थी और ये 15% थी, वही रख लेते हैं अभी हम. ठीक है. So अच्छा, अगर हम इसको बढ़ाएं तो इससे कुछ फर्क पड़ता है? नो, इससे तो कोई फर्क. ओके. तो 12% हमारा कैपिटल ए था, विच इज गेटिंग अस पॉजिटिव एनपीवी. 15% हमारा कैपिटल बी था जिससे नेगेटिव एनपीवी आ रही थी. उसके बाद ये फॉर्मूला है, फॉर्मूला ऑफ IRR और द फॉर्मूला ऑफ इंटरपोलेशन फॉर IRR इज that capital A plus bracket A, small a divided by small a minus b, small b, bracket close, and b minus a, b capital B minus capital A. These are the two rates, the difference of two rates. So by applying this formula, we will get IRR. Here you can see that I in the formula bar that I have used uh, all the values of capital A, capital B, small b, and by putting all the values in the interpolation formula, we have got 14.55% at the 14.55% at the rate of 14.5%. We are almost getting zero NPV from a project or zero NPV from an investment. I hope that the process of calculating IRR would be now very, if not very easy, but the understanding have been developed for the student that how we are going to calculate NPV. So in the next section, we will discuss some of the drawbacks of, and not only of NPV, but we will try to rectify those drawbacks as well through modified IRR. So in the next class, we are going to discuss modified IRR, and we will also discuss the drawbacks of every techniques and the positive of every techniques. What are the pros and cons of every capital budgeting technique, and which technique is more suitable, we will discuss in the next session. So thank you very much, and we will be having another session with the break of 5 to 6 minutes. Okay, thank you.